On the AP exam, besides the calculus itself, besides the forevers that you might not have memorized, which hopefully you'll have memorized by tomorrow, and you'll keep on memorizing, making sure you have perfect by Monday, or by Tuesday. Monday and Tuesday, sure. By Tuesday. Besides the calculus concepts, besides the little tricks and the little mistakes and the things where they put an answer that didn't use U prime and your brain just went too fast and you tried to do mental math, or you chose an answer that didn't include proper U sub, your brain went too fast, you tried to do mental math. Besides the places you might get tricked, besides the calculus that you might make a formula wrong or remember a formula incorrectly, etc., the trickiest part is when they give you real life situations, knowing what to do with it. When they give you words, knowing what to do with it. Which is why I can remember, for example, last year there was a problem AB kids hated about an escalator. Because when you guys are still finishing your exams, the East Coast kids have just gotten out of their FRQs when you're starting your FRQs, so I get to see memes about what they're mad about. Last year was an escalator, and BC kids was plankton. There were plankton, not as in SpongeBob, but you can imagine all the memes were SpongeBob. There was a plankton on the BC exam. The year before, there were bananas. There was a display of bananas. There was like bananas on a display. The customers start taking them. Then an employee comes on to start working a little bit later, like the ant and the snail. The ant started a little bit later. But the employee started throwing the banana, not throwing the bananas, but replenishing the bananas on the display. A few years ago, there was something about a gravel processing plant, which reminds me a little bit of grain in a silo. Some of you guys saw that in your mock AP, right? How many of you guys know what a silo is? It was better than the BC class. They were like, what's a silo? I'm like, picture of a farm. It's the tall metal thing. Have you ever been to the Midwest? Anyway, so we're seeing pictures of it. The silo is what holds all the like corn or all the wheat or all the whatever that they're storing up for later because it snows and there's no food being grown in the snow. Anyway, it's like the grain in the silo problem. Gravel processing. I don't know how that works, me either, but there's some conveyor belt and the gravel goes up and it gets dumped onto a conical pile. I don't know, but gravel processing, especially those for whom English is not your first language. It's like gravel processing plant. What is that? You're going to have to look beyond the situation to the math. And this packet, related rates, helps you with that. Because when you are given something, anything, when you are given something, anything, you're thinking of a situation. Maybe you're drawing a picture. I told you that back when we did related rates. Maybe you're labeling, constants, you can make them numbers, but things that are changing, quantities that are changing have to be variables. You're translating the words. Translate. Math is a language. You're translating the words into mathematical expressions. This would be the rate of D box, the rate of change of area with respect to time equals, as always is, 15 feet squared per minute. Or 15 feet per minute, if we want to do it that way. Try to figure out a formula or an equation. If they don't give it to you, it somehow relates. Take a derivative of both sides. And so they had you start off saying like, hey, guys, how did you translate the area of a circle is increasing at a rate of? dA dt equals positive increasing, positive 6 inches squared per minute. But down here when it said something like, hey, take the mathematical expression and put it into words, I'm going to use this one. The volume is decreasing at a rate of 28 feet cubed per minute is one way of putting it. But it could have been as basic as the rate of change of volume with respect to time is negative 28 feet cubed per minute. But the AP loves for you to say decreasing. Now here's the problem. Can you say decreasing at a rate of negative? Is that proper? No, that'd be a double negative, which is really a positive. I'm not going nowhere. Oh, you're going somewhere. Or you just have really bad grammar. But either way, don't have bad grammar on the AP. So if you use the word decreasing, that's what the AP loves. That's what the AP is going to use for the most part. Just don't put the negative. Now, we got down into the math. Starting in multiple choice number 1. I'm ready. Give me multiple choice questions. 1, 2. Okay, we'll start here. But guys, the key, I heard 1, right? And then I heard 2, yeah. Okay, the key is translating. So as soon as I see the radius of a circle is increasing, that's a derivative of whatever quantity, right? Increasing at a constant rate of. So I know d who dt, dr dt. Increasing means make it a positive, 0.4 meters per second. What is the rate of increase in the area of the circle? Find dA dt when the circumference is 60 pi. They're going to expect me to know circumference of a circle? Yeah, very possibly. So circumference of a circle is not pi r squared. It's 2 pi r. So you could set 60 pi equal to 2 pi r and figure out, wouldn't r need to be 30? And why am I doing that? Because if we're trying to find area, guys, what's the formula that relates area with radius? I want r's. I don't want c's. I want r's. Especially because that's a dr dt, which is why I took circumference and figured out what radius must be. Now, hold on, there are no dt's yet. Why? Because don't these come from derivatives of quantities? So what do I need to do to both sides? Make it proper, d dt. Derivative of a is dA dt. Derivative of 2 pi r. Isn't pi just a constant multiple? Constant multiple rule would just bring down the 2 to join the pi. We have r, but don't forget your implicit differentiation. I need my a prime the same way I needed my r prime. Or I should say I need my r prime the same way I needed my a prime. Now I can go ahead. This is a non-calculator question. So when we go to plug in 0.4, some of you are going to freak out a little bit. When we go to plug in 30, we end up with 2 times 30 is 60 pi. Some of you, though, might have done this work and realized 2 pi r just is circumference. You could have just thrown in the 60 pi either way. But then we have 0.4. I don't know about you guys. My brain works better in fractions. I would have made that 4/10 or 2/5, because then my brain can make that a 1 and that a 12, and I get a 24 pi. Double check my my units, but area would be something squared over time. Meters squared per second looks good to me. Is that cool? Number 2 is probably fairly similar in that they give you clues. Oh, they even give you the geometry equation. They give you clues and you're trying to find something that's unknown. And my guess is we somehow have to take a derivative of somebody. But let's figure out what our clues are first. What did you guys say equals -10 cubic centimeters per second? Who is that? dy dt? Not dr, but you're close. Cubic centimeters? Yeah, gives me the clue it needs to be volume. But couldn't you guys look at your formulas and know it's either r or s or v? It's one of those. R is radius, which would be measured in centimeters. S is surface area, measured in centimeters squared. V is volume, centimeters cubed. So in this one, the volume actually helps, or you can think of what's changing if it's being deflated. The inside. Does that make sense? The volume. It says when the volume of is, okay, so V equals 256. That's my set. V equals 256 thirds pi. Volume is, we could put in the units if you want. What is the rate of change of the surface area? What is the rate of change of the surface area? Now we have some options. We could just kind of turn a blind eye to all the clues and be like, yay, we have equations, let's take derivatives. That's one way. Just go straight for the derivative and turn a blind eye to the clue. But why am I saying blind eye to the clues? What are the only variables involved in my clues right now? V's, besides the derivative, d dt, V's and S's. Is there a way to smush these two together with substitution? Is there a way to somehow get a formula with V's and S's alone? It's not going to be pretty, but yeah. Couldn't we have either way? Maybe I'll steal this guy. Couldn't we solve for r by, I don't know, multiplying by 3, dividing by 4 pi, and then cube rooting? I know you don't like it, but could we have? Yeah. For what purpose? If I want ds dt, but I only want v's, couldn't I plug this in for r? So if I look at all my clues, I only see v's and s's. I'm like, well, I could just go for it and then figure out life. Or I could change my formulas to be in terms of s equals 4 pi times 3v all over 4 pi cube rooted squared. Oh, gross. Cube rooted squared is nasty notation. Do you guys mind if I just make it to the 2/3 power? Is that okay? Now, isn't everything a constant besides v? You see that? And there's no addition, no subtraction, which means there's no need for or even possibility of killing puppies by distributing it illegally. So we can actually do some kind of crazy bringing all the constants together. So I could do 3 to the 2/3 all over 4 pi to the 2/3. I could bring my 3 to the 2/3 out. I could bring my 4 pi to the 2/3 out, and I could just say, hey, times v. I know it's nasty, but I can do it. And the purpose being, I need to take a derivative, don't I, guys? So can I take d dt of both sides? And wouldn't I get ds dt, the dude I want, equals, I don't know, that whole nasty coefficient. We'll figure him out in a second if we have to make him match. All over 4 pi to the 2/3. Constant multiple says just take his derivative, so dv dt, and don't I have a clue to plug it in? Plug it in. Don't I have a clue to plug it in? Plug it in. Oh, wait, sorry, what power is my v? That's why it's a little bit weird. My v is to the 2/3 power. Oh, sorry, I knew something was a little too pretty. We need to bring down our 2/3 and make it v to the negative 1/3, which would move it down here, of v times dv dt. So now I can plug in both clues. This guy's going to go there. That guy's going to go over there. So the math is getting a bit messy in this one. I wonder if I can, oh good, I can pull them down. So this guy's going to be negative 10. This guy's going to be 1 over the cubed root of 256 pi all over 3 times 2/3 times 4 pi. Read that now. And how pretty is this? The answers are up above. Yeah, wouldn't we love to be able to, I don't know, maybe make this look prettier with a calculator and then compare the decimals? But sadly, this is a non-calculator question, so there has to be a way to simplify. I see a few things, like for instance, this is 4 pi to the 1, and that's 4 pi to the 2/3. So we technically could do a little like, okay, 1 minus 2/3 would be a 1/3. So I could have 4 pi all underneath a cubed root up top. I have 3 to the 2/3 over 3 to the 1. 2/3 minus 1 would be negative 1/3. So I actually have a cubed root of 3 down here. So I've put those two together. I've put those two together. I have 2 times negative 10, which would be times a negative 20. And then I have this dude down here, which is the cubed root of 256 pi all over the cubed root of 3. The cubed root of 3 actually ends up canceling out. My 256, if we were trying to cube root him, stuff goes into 256. 4 goes in, quite a few 4s. If you needed to, off to the side, we totally could divide by 4, which would be 64, which is 8 and 8, which is 2 and 4 and 2 and 4. Oh my goodness, look, I have 4 cubed in there. So I could actually pull out, let's see. So this must equal 64 times 4. Oh, duh. And 64 is 4 cubed. Okay, so the cubed root, 64 times 4 would be 4 cubed root of 4. So I can rewrite this guy to be 4 times the cubed root of 4 pi. Oh my goodness, the cubed root of 4 pi cancels. I end up with negative 20 over 4, which ends up being negative. Whew, double check me. That was a lot of by hand mental. Pause. Up to you. Would you have seen pretty quickly, I think, once you started taking derivatives, that this one's going to get really nasty really quick? As soon as you see it's going to take a lot of time, it's up to you. If you have any clue as to an answer, you could pick one, put a star, and come back. It's up to you as to whether or not, as you're taking these mock APs, you're running short on time or not. But if you're running short on time, I wouldn't waste a lot of time on this one problem. Does that make sense? Okay. Let me take one more multiple choice question real fast. Anything else on multiple choice? Sorry, there was a lot of by hand work on that one. Going once, going twice. FRQs? Yeah, Ryan. Okay. Go ahead and grab out your mock APs, guys, if you don't have them out yet, so we can go peek at FRQs 1 and 2. 1C, I'm just going to peek up here to see what the givens are. We know dr dt is equal to 0.8. We know dr dt is equal to 0.8. Okay. So we have, help me out, the orientation decided to go off in the worst times. And I know dr dt is equal to 0.8 centimeters per second. Cool. When the radius of the circle is 5 root 2, so in my mind I think of love you, computer. I really don't, though. R is equal to 5 root 2. What is the rate of change in the shaded area of the region outside the square but inside the circle? So if I'm thinking about area outside the square but inside the circle, wouldn't that be pi r squared, the big one, minus s squared, the little one? But hold on. The square, how do I figure out the side of the square? This is radius, right? Which means that would be diameter, because there's 2 radii. That would be the diagonal of the square. This in terms of the same variable. I'm not sure if you've had to do that before. But I would think of a square that has s and s. Then we just talked about how this is 2r. So to be honest, Ryan, I would have done Pythagorean theorem. That a squared plus b squared is equal to c squared. You can use that this is the diameter, this is 2r, to figure out another way of relating these two together. So s is equal to 2r squared square rooted. It meaning the answer?
The sides of the triangle are 5.
Oh, at the such that. Okay, yeah. So that's just for the very end, though. We only plug in clues at the very end. So I would need to do dA dt is equal to 2 pi r dr dt. But I was trying to get this in terms of r. See, now it's magically working again. I would have plugged in root 2r squared, which would have been pi r squared minus 2r. So then you would have had an additional 2 dr dt. So you were trying, I think, to keep the r's and keep the s's. I was trying to get rid of the s's, so I didn't even have to deal with it. So your way wasn't necessarily wrong. You would have just had to do something like this. Relate ds dt with root 2 dr dt. So you would have had to plug in the 0.8 to get the ds dt if you had stayed here, taken the derivative, and plugged in your, whatever you got your s to be, which is 5. that what you got? But for mine, I would have just gone all the way to r, so then I could go ahead and plug in my 2 pi times 5 rad 2. I could technically pull out the dr dt to be 0.8. And my final units would have been centimeters squared per. But I'm sure their answer is nice and pretty and simplified, so it's going to look a little bit different. But this is what you would have needed if you had found the s's, which were good, but you would have also had a ds dt that you would have had to somehow relate to the dr dt. Does that kind of make sense? Okay. FRQs 1 and 2. Guys, the video from yesterday was from period 6, I think. No, it was from you. Never mind. Sorry, the video was from you, and they were checking out because they didn't ask very many questions on the LTF, which is how we got ahead. But is there anything on the grain silo problem, which I think was 2018? Was that right? Saturday, which is what almost everyone took. Anything on the grain silo problem that you guys want to talk about in depth? A, B, C, D. Anything on number 2, which was the snail and the ant? C and D. The key of number 2 is that they're giving you a velocity that we have to use in between 0 and 15 for the snail. So the snail's going the entire time, 0 to 15. The ant doesn't show up until letter D, I think. Letter C, well, I wish I had recorded period 6 yesterday. Maybe I should have. If you guys check out the video from the BC kiddo, this, and hopefully they did it right, this was so easy if you just used your calculator. Because you can take a derivative of something and plug in 5 just like that on a calculator. All you need to do is show me work. As far as the expression equals the answer with correct decimals. This one, so easy with a calculator. It's the integral from a to b of plug in v of t. So easy. Strict forever cards. But then it got a little bit funnier. However, which theorem states instantaneous equals average? Instantaneous rate equals average rate. Which theorem? MVT says take the derivative and set equal to the average. But in this case, it's a little bit harder because this is what MVT says. But that's not this problem because I'm talking about instantaneous velocity, which would be v of t, or x prime, which we know is v from what they gave us, equal to the average velocity. They gave us velocity. We're given velocity. So this one's awkward because you weren't doing an average rate of this. You were doing the average value of this. Average velocity is change in position over change in time. Velocity is change in position over change in time, which only comes when you anti-derive velocity. So average velocity, average of what they've given us. You could have, and I think you actually already found this number in letter B, right? So you would have done 1 over 15 times, from yesterday it was 70. I'm going to put a dot, 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 because hopefully you wouldn't have rounded it when you used it in a future point. But then you have to set the velocity, which is the instantaneous velocity, which is x prime. So we have our instantaneous velocity, and then we have our average value of velocity that we have to set equal to each other. Now, guys, they gave this to us. It should be in your calculator. What do we go looking for in our graphing calculator with an 0 and an x max? Not that you would need to show them this. That's just for you to think about. I'm crossing out because AP graders can't grade what you cross out. X min, X max, make your window. What are you looking for if you graph two things and want them equal? Intersections. But if it's off the zoom standard window, couldn't you just move this to the other side and find the zeros? Yeah. If you could, the problem is you guys don't know how to, and actually even BC struggles with how to integrate a strict ln. But if it was an integrable, if it was one that you could integrate by hand, yeah, you could have just gone to position and then done change in position over change in time. You could have even done position prime. Does that kind of give you a direction, Rachel? In letter D, though, it gets a whole extra level of hard. because letter D brings in this ant dude that doesn't start until time t equals 12. Now, we have options for the ant. I'll show you what I think is the easiest one. One option for the ant is to make him a piecewise function and say, like, he was not traveling on the snail's path for t less than 12, but he was for t greater than or equal to 12. That's one way to talk about the ant. But an easier way to talk about the ant is, here they go. They tell us constant acceleration of the ant. The ant, I'm going to put a little a for ant. The ant has a constant acceleration of 2, but that's only for t greater than or equal to 12. So we could go making a piecewise function and say it's only for t greater than or equal to 12. Or we could do the following. Or we could say, you know what, instead of making it just in terms of t, I'm going to make it in terms of time from 12. I'm going to make it in terms of time from 12. So instead of having the acceleration of t, I'm going to have the acceleration of u, where u is the number of minutes since 12. So when I go to find the velocity, and I go to integrate 2, because to get from acceleration to velocity, I integrate. When I integrate 2, I'm not going to have 2 times t, I'm going to have 2 times u plus c, except a little bit later they tell us the initial velocity at 12 is actually plus b. So without making piecewise functions, we can say we're going to measure time. Well, they already tell us what time is. Time is how many minutes since the snail started. So I need the ant to have only gone 1 second at t equals 13, and only gone 2 seconds at t equals 14, and only gone 3 seconds at t equals 15. So instead of integrating to get 2t, we should integrate to get 2u, where u is the number of seconds since 12. Why am I doing that? Well, because I need to get back to position of the ant. And to get back to position of the ant, I'm going to have to integrate again, which I can do. I can make this cubed over 3, so I'd have 2/3. The reason I'm doing this fast, sorry guys, is because the u sub is going to be, oh sorry, it's squared over 2, right? Plus bt plus initial position. I could actually have him start at the very beginning, which would just be 0. I'm trying to find the position of the ant, because don't we know how far the snail has already gone in those 15 seconds from letter B that you guys just told me was 76.04, something, something, something? Don't write a decimal wrong in one part that you had right in another, that'd be sad. But we already know how far the snail went. And what do we know at time t equals 15 about how far the ant's gone? Don't we know it's the same? Does that make sense? So the only little lapse in judgment, the only little error I made is, I apologize. I did not integrate b correctly. I didn't make him a u. That's my bad. I'm sorry. I forgot I was integrating with respect to u. But now I can say plug in 15 seconds, aka the ant's position at 15. Or I could even do like a definite integral if you guys want to instead. I guess the other variation of how you could have done this was do from 0 to 15. Nope, it's not going that far. From 12 to 15 of my we could have, if you want it, if it's a little bit easier, we could do the displacement of the ant over the 12 to 15 seconds needs to equal the displacement of the snail. That's probably a little easier. I was going back to the position function. You would have had to find your, this one you can use your calculator a lot more in, because we can do definite integrals from 12 to 15. That's probably a little easier. Because we already know what this answer is, 76.04. We could plug part of this into our calculator, because we could totally plug in 12 to 15 of our 2 times t minus 12 dt. We would just have to solve this guy by hand. That's okay. I can solve this guy by hand, and that I can go ahead and do 15b minus 12b plus, throw that in the calculator. They totally can, but to be honest, you wouldn't have even had to show that decimal. because whatever this decimal is that you would get from your calculator, maybe it's a nice answer, maybe it's not. Technically, all you have to do is just move him to the other side by subtraction and then divide by, isn't that going to be 3b? So the hardest part in this one was getting the expression for acceleration. They gave it to you, is 2, but realizing when you integrate, you can't do 2t where t is the number of seconds from 0 because the ant is not moving from 0, the ant is moving from 12. And so having this removal of time and thinking about it with an integration of u's, where u is the amount of time from 12, is where a lot of you guys got stuck. But once we have that expression, cool, displacement of ant equals displacement of snail. Part of this I can do in my calculator, but the part with the b I kind of have to do by hand, in that this antiderivative would have been bt, if you guys didn't see what I was doing from 12 to 15. So a little bit of by hand. It's just plug and chugging to your calculator. So subtract, divide by 3, and you have your final b. There was a CalcBC kid, remember, that tried to explain this. Maybe their explanation's better than mine. I started to go to position when I should have just gone to displacement. That's probably a little easier as far as thinking about the problem. But that was number 2, the hardest part, I think, from 2018. My people that took it Wednesday. Oh, 45. That's when we're getting out. My people that took it Wednesday or did the other mock AP, we have chili powder. And then we have board games. Anything you guys want to see between chili powder and board games? Okay. Here's what I'm going to do as far as taping today. Didn't I tell you period 6 did numbers 1 and 2 yesterday? And they had questions on both. I think we ended up doing something on the board games because the board games also had a removal of time. In letter C, if you want to get another one of those removal of time things, this guy was saying that, hey, starting at week 12, things are going to change in the sales, which makes sense because at first, like, oh, lots of sales, and then it kind of dwindles off. Anyway, so a removal of time. There was the banana problem from 2 years ago, all removal in time. Anyway, so in period 6, what do you guys think we're doing today? 3, 4, 5, and 6. I'm taping you guys so that we get some questions on 1 and 2, but then I'm taping them also. So I'm putting up 2 videos from today. Why would I be doing that? Is our Forever Final going to take time tomorrow? Yes. And if it takes time, what will there probably not be as much time for? Now, no new LTFs, but some of you are like, I haven't finished my FRQs. So quick reminder, what's in Google Classroom underneath the announcement where the answer keys are? Videos for each of the FRQs to help you out, right? But you might have some additional questions. Check out whatever period 6 asks as far as their questions they need clarification on or what they didn't like from the videos on the Wednesday and Saturday APs. Does that make sense? And that way tomorrow, if you guys do have additional questions, hopefully it would be above and beyond or needing just a little bit of extra clarification from the BC videos and then from period 6's questions today. Is that cool? Okay, there is one thing I talked about with period 6 and BC yesterday. I'm not sure I did with you guys. Do you remember how bonus practice exams, the 2003 from after spring break, the 1998 technically is still available for you guys to do? I meant to load up some this past weekend. I totally forgot. Do you guys remember, though, how I told you you could search AP Calculus free response, right? And hopefully the top ones are going to be College Board. I mean, you could probably find other random crappy ones. But anyway, the top ones should be College Board. Now, if you hit College Board, be careful that you're doing AB and not BC. Check right here. They actually just come up with 2016, which is a couple years ago, but you can search 2017, you can search 2018, see the FRQs from last year, see the FRQs from 2 years ago. If you guys hit on this, you have blank FRQs. Now, how much of a bonus, how much of an AP exam are the FRQs? Half, right? So can I give you all the points for a bonus practice exam if you do FRQs only? No, but can I give you half? Yes. Some of you guys, FRQs are one of your weakest points as far as you've seen things in the LTF. Multiple choice are probably better practice FRQs. Just need to start playing. Yeah. 18, 17, 16. There's a whole library of them. All you got to do is print them out, try them, grade them with the scoring guideline. 2 points, 2 bonus points in your test quiz category. Yeah? Okay. So, even though I haven't posted full-length bonus exams, what have I just opened the door to? So many bonus practice problems, right? And some of you are like, oh, I think I could bust through FRQs even easier than, or faster than multiple choice. I'm not sure. Is the bell not ringing today for pep rally schedule?
It rings at 47.
Oh, okay, so we still have 25 seconds. Okay. So, what am I basically right now trying to do for you? Give you the freedom to study the way you need. Meaning, I'm forcing you, hopefully by tomorrow, to do what? Study your forevers. Finish up your corrections. You have a full-length other mock AP if you haven't taken it yet to try. Then you can check out our videos to see if people ask questions, etc. But I also opened up all the FRQs. You can go find a year and just try your best, grade them, and if you have questions, I'm here after school most days. Sound good? All right. Bye, guys. This is not a me, don't study. This is a me, I know you're all different. It's time for you to take charge of what you need. My batteries are officially